Welcome to IBK Innovations. So let us solve one question. The problem given is draw the grain size distribution curve and determine a uniformity coefficient and coefficient of curvature for the following data. Okay, and they mention the different sieve size, that is 4.75 mm, 2.36 mm, 1 mm, 425 micron, 150 micron, 75 micron, and pan. For 4.75 mm, the weight of soil retained is in Newton, that is 12, and for a sieve 2.36, weight of soil retained is 18 Newton. For 1 mm sieve 950 Newton. For 425 micron 933 Newton. 150 micron 1338 Newton. For 75 micron 895 Newton, and the weight retained on the pan is 100 Newton. So here we can directly consider in Newton, or we can also convert that Newton value into gram, then we can proceed as usual. For conversion factor, it doesn't affect here. So in this problem we are going to take the values of in Newton to find the percentage final. Now prepare the table, that is ISU in mm, weight of soil retained in Newton, then cumulative mass retained, then percentage cumulative retained, and last one percentage final or percentage passing. Then prepare the table. The first mention is here ISU in mm and weight of soil retained in Newton. That two values are mentioned in a given problem, and we have to write here prepare for, and we have to find these values: cumulative mass retained, percentage cumulative retained, and percentage final or percentage passing. First, let us find cumulative mass retained. This cumulative mass retained can be found out by, first we have to write the value of weight of the soil retained as it is in the cumulative mass retained column, that is 12, and for finding the next value we have to add cumulative mass retained with this weight of the soil retained. That is 12 plus 18 gives the value of cumulative mass retained. 12 plus 18 gives cumulative mass retained, that is 30. Then next value is found out by 30 plus 350 gives 30 plus 950, 30 plus 950 gives the value 980. Then again 980 plus 933, which gives the value 1913. Likewise, next value plus 1338 gives 3251. And next value 895 which gives 4146. Next last value plus 100, 4246. So to find the cumulative weight retained, we have one formula, that is cumulative percentage cumulative retained is equal to cumulative mass retained divided by weight of sample taken into 100 gives us the value of percentage cumulative retained. So let us do first value, that is cumulative mass retained divided by weight of sample taken, that is total weight of taken sample, into 100. For first value 12, that is 12 divided by total sample taken, that is this values, last value 4246. This one is the total sample taken. 4246 into 100. 12 divided by 4246 into 100 gives the value 0.28. And similarly next value 30 divided by 4246 into 100 gives the value 0.7. Next value 980 divided by 4246 into 100. 980 divided by 4246 into 100, 23.08. 23.08. Next value 1913 divided by 4246 into 100, 45.054. Okay, next value 3251 divided by 4246 into 100, 76.56. Next value 4146 divided by 4246 into 100, 97.64. Last value 4246 divided by 4246 into 100, it is 100%. Next we have to find the percentage final. The percentage finer can be obtained by subtracting the value of cumulative retained, that is 100 minus 0.28 gives the values of percentage finer. 100 minus 0.28, that is 99.72. Next value, 100 minus 0.7 gives the value 99.3. Next, 100 minus 23.08, which gives the value 76.92. Next, 100 minus 45.05 into 100. 100 minus 45.05, which gives 54.95. Next, 100 minus 76.56, which gives the value 23.44. Next, 100 minus 97.64 gives the value 2.36. Next, last value, which is 100 minus 100, 0. This is how we got here. Then we have to construct. Finally, we constructed this table. Now we have to plot a graph on semi-log sheet. We have here a semi-log sheet. On this sheet we have to plot the graph to find the coefficients. Next here we have to plot the graph sieve size on x-axis and percentage passing on a y-axis. Here we have to mention 0.1 sieve size, 1, here 10, and here 100 goes on. Next, on y-axis 20, 40, 60, 80, 100, that is percentage finer or percentage passing. So here guys, we got for sieve size 4.75 mm sieve, the percentage passing is 99.7. so the value we got here 4.7, and next 99.72 we got somewhere here. Next we have to put the value of the sieve size 2.36. The value lies here 2, 1, 2, 1, 2, 3, 3, 6 something here, 4, near 4. Next we have to find the value, that is 99.3 corresponding to this. One 92, 93, that is 99.3, somewhere here. Next we have to search for 1 mm sieve. Where is 1 mm is here, and the percentage passing is 76.92. 76, it is 60, 62, 64, 66, 68 and 70, and 70 to 7476.92, somewhere here. Next, for the sieve size 425 micron, that is 0.425, 0.1, 0.2, 0.3, 0.4 and 0.425, somewhere here. Next, for this value we have 54.95. On y-axis we have to search for 54.95. 50, come over here, 50 to 54.95, somewhere here. Next value is, finally we plotted the graph sieve size and percentage finding, and our graph looks like this. This is a curve. Then we have to find the coefficient of curvature and coefficient of uniformity. It is given by the formula d30 square divided by d60 into d10, and coefficient of uniformity is given by d60 by d10. Here d30, d10, d30, d60 value can be obtained from drawing the straight line over d10 where it cuts on a curve, and we drop this point on a x-axis, and what we got, that value of the sieve size, that value is the d10 value. That is, we draw one straight line to find here which cuts our curve for d10. Let's draw this point on a x-axis. We got here 0.11. That is the value, 0.11. Similarly for d30, what's over here, d30, then that is 0.18, this value. Write d30 as 0.18. For value of d60, again draw the straight line from here which cuts our curve, then drop this point which gives the value, which gives here, this one is 0.2, 3, 4, 5, 0.53. D60 is 0.53. Then substitute in this equation d30 square 0.18 square divided by d60 into d10. We will get here 0.18 square divided by 0.53 into 0.11. That gives the value 0.4 5 5, and similarly d60 by d10 0.53 divided by 0.11, 0.53 divided by 0.11, 4.8. This value is greater than 4, that is for well graded size. For well graded size, value of CC must lie between 1 to 4, but we got here less than 4, not in between 1 and 4, and value of CU must be greater than 4, but we got here value CU greater than 4, but you have to write here, but in above condition CC is 0.55 and CU is 4.81, hence the soil is poorly graded soil. Thank you guys for watching this video. If you like this video and if you want to receive many more other related things about civil engineering or other materials, please subscribe, which is given below in the red box mark subscribe. Please click on that and subscribe and stay updated for this channel. Please guys, thank you for watching. See you next time.